On Thursday, January 16th, we saw the first ever launch of SpaceX's new and improved Starship Block 2 vehicle. While no one can deny that this rocket put on one hell of a show, it also failed catastrophically. So what happened there? Well, let's figure it out. In the lead up to Starship Flight number 7, everything was looking beautiful at Starbase. We had nice late afternoon sunlight, clear skies, a little bit of wind, but nothing to be worried about. We're all very excited to get our first look at the capabilities of this upgraded V2 Starship vehicle. The pre-launch rundown showed off some new video of the ship's payload being fitted in through a slot on the back. Those are Starlink mass simulators, essentially just chunks of metal in the same shape and weight of a Starlink V3 satellite. Those are being loaded into the ship's PEZ dispenser for deployment while in space. This Block 2 Starship has been fitted with longer propellant tanks that hold 25% more volume than before, amounting to about 300 metric tons of additional rocket fuel to help carry that new payload weight. We also got a really cool look at the new heat shield tiles that are being tested on this launch. Yet again, SpaceX has made the call to remove several of the black hexagonal tiles from areas all over the body of the ship. They've also dedicated one section to experimenting with new metallic tiles, one of which has an active cooling system, which essentially means that cold liquid, probably rocket fuel, is being flowed through the tile to expel heat, very similar to the water-cooled steel plate that's below the Starship during launch. And even though the Super Heavy booster for this launch is not a new design like the ship, there is something very special about this booster. It's been fitted with the Raptor engine that was previously flown in October 2024 on a Super Heavy that was caught by the Mechazilla Tower, Raptor number 314, the Pi engine, ready for round 2. And on booster ignition, everything is going smoothly. We get all 33 Raptors igniting, and the rocket moves quickly off the pad. The sound on this stream is excellent. We get that very clear crackle from the rocket engines that comes from the exhaust plume breaking the sound barrier. We also get a much better downward-facing camera angle this time. We can see more of the rocket body as it ascends, and that also gives us a view of this little piece of sheet metal on the far left side of the screen that seems to break loose and start flapping in the wind. Remember that one for later. But flappy metal aside, everything continues to go beautifully. We get a clean hot stage separation as the ship engines ignite with the booster still attached. The energy from those upper stage engines pushes the booster into a backflip maneuver, and shortly after that, we get our boost back burn. This time around, one of the middle ring engines fails to restart for the boost back, but that doesn't seem to bother SpaceX at all because we very quickly get the call out that booster is go for return to launch site. After making a final separation from the interstage ring that's clamped to the top of the booster, it gradually steers back towards Starbase. The heat from all of the air pressure built up underneath the booster as it free falls makes the engine nozzles glow red, but that doesn't stop them from lighting up to begin the final landing burn. This time we get all 13 of the middle and center ring engines, so we've learned something new here. The engine that failed to restart for the boost back managed to fire up just fine for landing. And from here, we get a pretty spectacular view of the second ever Mechazilla chopstick arm catch of a Super Heavy booster. This time around looks much more clean than what we saw back in October. Very minimal fire involved, just a bit of smoke coming off the booster, which would not be unusual given everything it just went through. This time around, the chopstick arms seem to close in on the booster much faster and more confidently than before. The SpaceX presenters mentioned earlier that the arms are now equipped with radar sensors to help in measuring the distance to the rocket. And now, while we're all very distracted by another successful booster catch, things start to go very badly overhead on the ship stage. It was easy to miss. I've just got a note that I took reading weird engine telemetry from ship at 8 minutes and 30 seconds. Turns out this was a little more than just weird telemetry readings, which is clearly what our SpaceX presenters are hoping for, but if we take a closer look at how the information on screen plays out, we can watch the beginning of the end for the first Starship Block 2. At T plus 7 minutes 40 seconds, the first ship engine goes down. It's a Raptor boost in the center cluster of 3 engines. That's the same type of Raptor used on the Super Heavy booster for launch. At the time of the engine out, the ship is 141 kilometers above the Earth, traveling at 17,800 kilometers per hour. Shortly after that first engine dies, we can see another important clue in the little illustration of the Starship. This shows us the attitude, or angle, of the rocket, and we can see the nose begin to move in a downward direction. At T plus 755, we go back to a camera view from the ship. This is pointed directly at the backside of the rear flap, and if you look at the bottom edge of the frame, just to the right of the time clock, we can see a hinge mechanism. And if you look closely, you can see flames licking up from inside the Starship and coming out through that hinge. This is not good. Even with all of this going on, Starship continues to gain speed and altitude. At 8 minutes 3 seconds, the second of the Raptor boost engines goes out. That's followed quickly by one of the outer ring vacuum engines going down. These are unique to the ship's stage and have big, wide nozzles for higher efficiency in the vacuum of space. We are now at 144 kilometers altitude and 20,000 kilometers per hour. Looking closely again at the telemetry, we can see that the angle of the ship is now totally flat. The nose is no longer pointing up, and it starts to even pitch down a little bit back towards the Earth. At the same time, we can see that the ship is depleting its methane tank at a much higher rate than its oxygen. At 8:18, the second Raptor vac engine goes out. The ship is 145 kilometers altitude, 21,000 kilometers per hour. The nose actually begins to pitch back up towards the correct angle, but then we lose the third center boost engine at 8:24. The methane